Happy holidays. Lady Ada, what is this?
Gobble, gobble, gobble. We're here on the eve before Thanksgiving, Thanksgiving Eve, where we have our weekly show and tell. We do this every single Wednesday, even before a major American holiday. It's me, Lady Ada, with me, Mr. Lady Ada, and we're going to have you, the viewer, show off your awesome projects. This is our show and tell. So show and tell what you're working on. We're going to be here till 7:50. Give us a couple of minutes so we can get ready for the next show at 8 p.m., which you can also watch. But we have a pretty good crew of people. Take three to 5 minutes to show off what you're doing. And we're going to start off with...
We're going to start off with Tony DeCola, and everyone this week is going to just say something briefly they're thankful for.
Mm-hmm. And then just mute your mic if you're not presenting. That way we don't get weird echo effects.
All right, Tony D, what you got going on?
Hey, yeah. So yeah, real quick, I guess I'm thankful for, I have a little vegetable spiralizer, which is what you can use to make like healthier versions of like pasta, like spiralized zucchini. So I use that thing a lot. It's worked well for me. But anyways, I wanted to show real quick. This is a little Feather TFT, and behind it is the ESP8266. And I'm just on my laptop. My main computer, for some reason, is not using video and audio. But it's drawing random lines on here. And this is all MicroPython, of course. So that's what I've been doing a whole bunch of videos and things on. So check out learn.adafruit.com/category/MicroPython. There's a guide that was just published that shows you how to draw on a display like this. So this is drawing lines. I ported over the GFX library that Phil B created for Arduino. So it lets you do line drawing, circle drawing, rectangle drawing, triangle drawing, basic stuff like that with any pixel display. So like this, or you could use something cool like maybe the Charlieplex LED matrix. Anything with pixels, you can draw shapes on it with this.
All right. Sounds like you're thankful for MicroPython.
That's true also, yeah. Python, more Python is always good, something to be thankful for. So.
All right. Next up, Scott.
Hello. I'm thankful for show and tell because I got an awesome job with y'all.
Whoa.
As a result of it. And kitties as well.
Yeah, Kat's got jobs too.
Yep, and Becca's in the background. I'm thankful for her too.
Hey.
And what I want to show today has to do with, I was digging into memory optimization, just understanding that for MicroPython. We were doing some drivers and we were wondering why when we structure drivers one way, it has different memory impacts than another. So I'm going to screen share. And this is a visualization of the heap. The heap is where Python objects end up when you make them. And so this is all of the blocks that make up the heap over time. So time is on your x-axis. So this is from restart. So you can see how objects are allocated as you go along. And then by hovering over it, you can see exactly like where in the code it got allocated. So you can get an idea of like what kind of object it is. And then this line here that happens at about 1,000 is the garbage collector going through and finding all the objects that are no longer referenced and deleting those. And I was just like digging into this because I was really interested. Like a lot of these early things that we allocate, we should actually be able to free up a lot earlier and potentially reduce our memory footprint. So yeah, hopefully we can make that even more optimized than it is now. And then all of the blocks here that go to this right edge are things that are still being used when the REPL starts. So this is all of the memory usage from the time that the board resets to the REPL prompts. So I've got a main.py here that loads the driver, and that's kind of what all of this bit here is. It's all the driver related allocations. So,
and what's the application or program or way that you're showing that?
Yeah, so it's I use GDB to collect the data, and then I process it with a Python script, of course. And then this is actually in Chrome, and it's using D3.js to render an SVG for me. So, yeah.
Okay.
It'll be checked into our repo shortly, and people can check it out there if they're interested.
Yeah, this is really cool. You can see how it's like, if you can maybe run that code that runs at around, tick 750, if you can run that earlier, you might end up compressing and not having so much, so many holes in the stack or the heap. That would be, that'd be great. Not that, I mean, those gaps are large enough, you can allocate memory in the middle, but it's always kind of like a pain to try
You
to
can see that it does do it. Like this allocation here is
Yeah,
done
I see
after
it.
a larger chunk.
And then like, oh, hey, a little sliver, but then it's like it never quite fits perfectly, you know.
Yeah, it turns out managing the heap is hard.
Turns out, yeah. Oh.
And they're pretty, like the MicroPython's pretty rudimentary. Like more advanced things can actually keep track of like, okay, now nothing cares about it, and so we'll free it right away. But this is just like, let me look at all the places I could possibly know about it. Like I'll mark all those, and then I'll sweep all the ones that I didn't see. It's called a market sweep. That's how it does. So this line here at 1,000 is the sweeping after it's gone through everything.
Yeah. Okay, cool.
Cool stuff. I heard you like Python, so we put Python in your Python. Look at the Python.
Mm-hmm.
All right.
Thanks, Scott.
Next, no, Pedro.
Hey guys,
Hey, guys.
Python on your wrist. Pedro, show me your wrist.
Before that, I'm going to say thankful for PLA and NinjaFlex, and keeping in the theme, of course, MicroPython. This
It's MicroPython time.
project is a wearable MicroPython OLED watch.
Nice.
Phil, this was your idea. Super cool for education.
Only if everyone likes it, then it's my idea.
Everybody likes their ideas.
Really? Okay.
So, totally stealing from the Nike watch bands that they came out with, totally using like the air little circles that they have on there. And the mind-blowing thing about this when Scott was still working on the mass storage for this is when you plug it in, it just shows up like a USB drive. You can check out all the code that's running on there. And that's, I think, a huge deal to be able to look at all your code, edit it, and for education, show the kids, you know, what's running to make all this work. And of course, on the design side, you can take a look at all the Fusion 360 files and edit the band so you can adjust it to your size. And of course, if you want to use a different board, you can edit the sketch that is generating all the solids for this. So super cool, simple little project. We talked about it more on this week's 3D Hangouts. And that's all uploaded, and you can check out the files and all of the source codes for that, like always, on learn.adafruit.com.
Well
Okay.
said.
And we're going to show that video on Ask an Engineer tonight.
Mhm.
Yep.
Real quick, I'm thankful for electrons and GPS and LTE, those things.
No, that's it. Okay.
Real quick, I am working on a new project that uses the Charlie Plex 9x16 LED matrix. And it's this little guy right here. It's a little retro pewter. Kind of looks like the PET from the 70s from Commodore.
Too cute.
It's kind of cute. Yeah, is that way? Yeah. So it's just running through the graphics demo that we have in the library. We'll do some interesting things with it. Right now, it just kind of looks cute. So
Yeah.
there you go. Sad
Good
face, happy face,
Beautiful cat.
all the faces. Cool.
All right. Thank you so
All right,
much.
sweet.
All right.
Okay. Next up, machines.
Okay. Yeah. Can you... Hello,
Virgil machine.
machines. Wait, we lost you.
Machines. Oh no, machines. Machines come back. Okay. All right. Andrew.
Hello.
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 So, am I really slow? I don't know. It feels really slow. Anyway, it's just a quick update on my flashing project. So, Adafruit Feather Huzzah right here.
Mm-hmm.
And bum, 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 bum. I'm going to screen share again.
Oh my God, I'm ready.
So, here we have Flasher.js, and right now on this board we've got Espruino, which is a JavaScript runtime. But as you know, the Feather Huzzah can also have Python installed onto it. So I've updated Flasher.js to include MicroPython. So you just select it from the drop-down and click Flash. And let me just close this.
Wow.
Maybe it's a bit confused because I had putty up, and let me just do it one more time. Flasher.js. Flasher, and then click MicroPython. So it's downloaded the binaries from the official website for you, and then it finds the device and it flashes it, and within a minute it's flashed on the device. So this works on Mac, Linux, and Windows. And you just download that, so there's no finding binaries. You can just select the binaries from the drop-down list. And anyone can contribute to the manifests for these binaries. So if you've got your own specific version of MicroPython, or this, that, and the other, you plug into this tool. And whilst it's flashing, I'm going to release it live. So version 1.1 is now live. People can go and download it for Mac and Windows. I'll have the Linux binaries up later this evening, and it's about 70% complete right now. But I just want to make sure that it actually does work, so I can show you.
We'll wait.
Yeah.
This is important. We will wait because this is
okay.
important.
Awesome. Yeah. It only takes a minute to flash, and it's flashed, so you should be able to see the MicroPython prompt. So
Yep, that's it.
right. So yeah, Flash.js is out, and it's MicroPython compatible. I've also released the Things SDK CLI for the modern workflow for JavaScript developers with all the tree shaking, so it gets rid of any surplus code for JavaScript, and it just only deploys the minimum amount of JavaScript to the device. And I've got a introduction video, which is about 7 minutes long, showing the process. So yeah, we're in the post Arduino era. That was coined, I guess, by you, Phil, the other week, and doing my part. And I'd like to say who I'm thankful for. Obviously, all the people who build the JavaScript and MicroPython runtimes, the people who design these boards and chips, and the community that I've got surrounding me that's helping to contribute towards this project as well. So I'm really grateful for everybody who puts in the spare time to make it easier for everybody to get into electronics.
Okay.
All right. Well, thank you so much, Andrew. Email support@adafruit.com. We'll send you an Ash Scene on the show and tell sticker. Back to the machines. Virgil, are you back?
We're back. I don't know what happened to us.
Yeah, we can hear you.
us.
We can't see you. Oh, now we get like we could see you one frame. So go for it.
Okay. Tell Lady Mission. Tell everybody.
So we made a banana piano. We had a little because we got confused by, and then we made it. And made it work. It's a circuit and labeled with C, D, E, and G.
Okay.
I was wondering if you would like to.
Okay, we did, sweetheart. So
we watched Hertz and F is for frequency, and then we about programming it.
Yep.
To make music.
I learned about music because read music and put it all together. So we have arts and science and.
Yep. Now come on.
Yes.
Lady Ada. Here, Mary had a little lamb.
I don't think she can hear. Are we?
We can barely hear you, but maybe try to play it. We might try to come back.
Okay. E.
Beep.
E. C. D. E. E. D. E. E. G. E. C.
Yay!
Did you hear it?
Yeah,
Yes.
we heard it. All right. Well, thank you so much. Email support@adafruit.com, and we'll send you an as seen on the show and tell sticker. If you remember, what are you thankful for this year?
We're at a
what do you think for this year? Woo!
I'm sure that without him.
I think it's thankful for Grandpa.
Thankful Grandpa.
All right. Well, we're gonna keep moving. All right. Next.
And come and visit to see my grandparents.
Okay.
All right. Okay,
Grandpa.
Morgan, unmute your mic and show us your project.
Hey, so today I'm in a new location, in a new state. So I'm thankful for new maker friends in new states. I'm now in a garage, which is pretty cool. My latest project is that I've done a little whack-a-mole game with using the circuit playground, and I stuck it inside of a mint tin. So here, let's see if this flips over. So I've got this mint tin. It's just one of the ice playground inside, and then it's just a game of whack-a-mole. So when the lights turn on, you press the buttons. If you get it wrong, these lives will turn up. So there's the wrong one. I did it wrong again. Oops, I did it wrong again. And so we got red lights. So
like a reaction timer? Like you have to hit the button in the right time, or you have to hit the right button?
Right now it's just the right button. There is like a 30-second timeout, or no, 3-second timeout. But I've got it written out on paper to get progressively harder as you go along. I haven't had time to actually implement that yet. But yeah, it's just a, oops, messed up again. Oops, messed up again. But I'm gonna add some more different colors, different patterns, and different noises to make it a little bit more fun. But yeah, it was pretty fun, and I'm happy that it all fit inside the container.
It's a perfect 10.
Yay, thank you so much, Morgan. Well, email support@adafruit.com. We can send a sticker that can go on that. Anything you're thankful for this year that you want to mention?
Just the maker community being really happy and accepting in new states. I showed up here last week and I already have a new maker space and new maker friends.
Yay.
Yay.
And mint tins.
And tins.
And mint tins, of course.
All right. Okay, next up, Andy, unmute your mic and show us your project. Hey, Andy.
My pajamas.
Hello?
Good, Andy.
We can't hear you.
We could hear you before, but now we can't. All right, you want to just hold up your project, Andy? Why don't you do Maker Charade? Just hold up the project, because we can't hear you. Oh, wait. Yeah, okay. Oh, it's a little...
Is this a lamp? What is it?
We're going to guess.
Okay, so it's a cardboard.
Oh, it looks like it's projecting.
Is it a projector?
Is that a mini projector?
Whoa.
Okay.
How does that work?
So it's a phone.
No, it's just a backlight for a phone that's lighting up a... It looks like a projection, but it's actually just a card, and it's projecting it, right?
Yeah.
It's hard to tell.
Okay, he's got...
Okay, different cards.
Different cards.
Different displays.
Yep, put the card in. Doop. And then when you put the light on it, it shows other things because it's a special type of light.
Oh, it's UV. Is it UV ink? Hard to tell what's going on.
Yeah.
I mean,
I think it reveals
No,
more.
it's just different color effects.
Yeah.
So it's neopixels, but it just kind of has a cool posterizing effect.
Yeah.
Because of the ink color.
I see something different each time.
Okay, well, you see something different every day.
All right, you got it.
Okay, that's cool. For a second, I thought it was like a micro projector.
Yeah.
I was like, how'd you get that working?
All right, Andy.
That's cool.
Well, thank you so much. Email support@adafruit.com. I'm thankful for Maker Charades. I'll speak on your behalf. Okay. Next up, Roberto. Unmute your mic and show us your project.
Hey guys, can y'all hear me okay?
Yep.
Yeah.
All right, cool. Today I have a quick one. It's kind of a work in progress. Before I worked on RGB LED matrices using Al Link's board with the Pixel. And recently I saw Frederick's post about getting a frame for the Pi Hat to control that. And trying to get the fully Java Enterprise Edition compliant app running. I tried that with the Pixel, but there was some incompatibility. And right now, my birthday's near. Thanksgiving and Christmas is near, all within kind of the same month. So I kind of have built in a lot of days off from work, and I'm going to try and pull together another RGB LED matrix application that's web enabled, but this time using the Pi Hat and not needing a separate PIC board. And so this morning I got the fork running, sorry, the original C++ implementation, and it's using the Hat, and it's just using an animated GIF. In the coming weeks, I hopefully have a port of the, sorry, I don't know if I'll be able to do that, a port of that application that just uses Raspberry Pi and the Pi Hat. So I'll come back and visit, as I get more of that implemented.
Totally.
And for family and friends and opportunities to share the projects I've worked on.
Yeah.
Thanks for having me.
Thank you so much. Email support@adafruit.com. We'll send you an SE on the Show and Tell sticker. And thank you everyone so much for stopping by. I think Show and Tell, we've been doing this for like 5 or 6 years.
Yeah.
And it's the thing that we're most grateful and look forward to every single week.
It is the most fun.
It is the most fun. So thank you everyone so much. Thank you, Machines. Thank you, Tony. Thank you, Scott. Thank you, Roberto. Thank you, Namita. Thank you, Morgan Mix. Thank you, Andy. And thank you, Andrew. We'll see everybody on Ask an Engineer in just a few minutes.
Andrew, you're having way too much fun with that feather. Yeah,
that's fun.
I've gone mad, I say.
Yeah. And we'll see everyone in just a few minutes.
Okay.
Okay, bye-bye.
Thanks, everybody.